Okay, 2-6 ratios and proportions. This actually may be one of the most just directly, simply applicable things that you can learn, and hopefully you will take this and remember this stuff for the rest of your lives, because this is something you can use every single day. And the most basic and simplest example is cooking. When you're trying to cook anything, or I don't know if you guys do baking. Baking's a lot more difficult because you have to maybe do some math using ratios and proportions. So, what is a ratio? Well, it's simply a relationship, right? Relationship between two numbers. And my example, I always use, I don't know why, because I like to make it, I guess, is pasta. Pasta dough. And it's really easy to make pasta dough as long as you have a pasta roller machine, right? A machine roller. You just need flour and eggs. And you can add in some olive oil or salt and other stuff too. But even if you just have these two things, you're good to go. So the relationship between these two, to make good pasta, you always have to have the same ratio or the same relationship, amounts of each ones. Okay, so you need 2 cups of flour for about every 3 eggs. And this is how I make it every time, and then you knead it together and blah blah blah. So my question to you, and you can pause the video and think about this and try to figure it out, and if you can, then hopefully you're pretty much good to go, is what if I have exactly 7 eggs? How many cups of flour do I need? Okay, so if I have 7 eggs, right? If I want to make pasta and I want to use all 7 eggs up, I've only got those. So this really, really wonderful thing. It's called proportional equality, right? Where if I have this relationship, this proportion, I'll have, say, 2 cups of flour. I'll put F for flour for every, and I'll put this one maybe in blue, for every 3 eggs, right? I can set this equal. And then I'm sure we did this in class, or you probably even learned it maybe in pre-algebra or something. But what's cool is you could set this equal to however many. You set one, you choose one that you want to use, like the eggs. We chose 7, so I'll keep that in blue, right? 7 eggs, and the E is not like a variable; it's just a unit in this case. And then I want to find out, a question mark, right? Flour, how many cups, right? Make sure you stick with the same units too. So how many cups of flour, question mark, right? Or X or something. Okay, so that's the really beautiful thing, is that if I say that these two things are equal, then there's this thing called the constant of proportionality. That's what I was trying to think of, because it's a really long name. Constant of proportionality. Don't worry about it. Really, all it is to shows you that this relationship here is the same as this relationship here, and we can find that out by if I were to divide these two numbers and then kind of divide these two numbers and set them equal to each other. Well, that's exactly kind of essentially what we do, but we use these cross multiplication, right? They always say cross multiply when you have fractions equaling each other, and that makes sense. And well, let's go into more detail about the cross multiplication later. It works. You guys, I'm sure, have been using it forever. So essentially, we end up getting 2 times 7, right? 2 times 7 equals 3, and let's call this x. All right. Whoops, that should be red. 3x. So but this is the really neat part, is that you set these things equal to each other, so I'm going to find this x, right? X here. I'm going to find some number that makes this relationship valid, and not just valid, but makes this relationship exactly the same as this relationship. And that's the kind of neat thing that we're actually doing. So now we just solve it. Okay, we know how to do that. This is something multiplied times x, so I'm going to use the multiplicative inverse, which is the multiplying by the reciprocal on both sides. Multiplicative inverse. And 2 times 7, we can just do that, 14, so that's 14 over 3 equals and this cancels with this. I kind of didn't put them next to each other, but we have that nice thing called the commutative property. I could move it over there. Equals x. So I need 14/3 cups of flour, right? So let's make sure we put our units. 14/3 cups of flour. And this is one of the only cases, in my opinion, that mixed numbers start to actually, be really useful, because this is hard to kind of think about. So let's divide by 3, 12. That's 4 and 2/3, right? 4 and 2/3 cups of flour. It would be our final answer here. Okay. So what did that actually tell us? It told us that we have, for 7 eggs, we need 4 and 2/3 cups of flour to make pasta dough. Yeah, but the nice thing is, well, that's just for this specific recipe of pasta dough, right? If we changed our original proportion, we would get a different number here too, right? So that's what I think is really cool, and hopefully you guys can see that this one's actually truly directly applicable to your life, and you can use this for all kinds of things, like making kombucha, or that's like kind of a brewing process, and that's got to be really exact. There's tons of other things like recipes and things like that. So I hope you guys do use this stuff. But let's do another example. Okay, so let's kind of zip through these guys pretty quickly here. We cross multiply. Oh yeah, in the book, you have all these ones where does this form a proportion? Well, if it is a true proportional equality, then I can, if they're equal to each other, then if I divide them, then the number that I get when I do this division equals this division, right? So I could just divide and check, because remember, the fraction sign is just division. But it says, practice your cross multiplication. So let's do that. Let's do cross multiplying and try to do this quickly. Let's see. So 14 times 2 is, okay, 14 times 2 is, and then let's put question marks because we don't know if it's true yet. 8 times 3.5. All right, that's what we want to know. All right, so this is 28, and then I don't know, I have to do this one over here on scratch work. This is 40. All right, 8 times 3, that's 24. 28, 1 decimal place. Good, 28. Okay, that's a check. So that one works. Let's get rid of this scratch work. You can keep it on your paper, but I run out of room here. And how about this guy here? So cross multiply to check. Remember, you could just divide also, because the fraction bar is division, right? So 0.3 times 2. Is this equal question mark? Is this equal to 1.5 times 0.5? And excuse my decimals and multiplications are looking a little similar. All right, 3 times 2, that's 0.6, right? Okay. And then we've got over here 1.5 and 5. I do scratch work here. 5 times 5 is 25. 2, 7, 1 decimal place. 7.5. So that one's, is that equal? No, it's not, obviously. So that's a no. This is not a proportion, or not a proportion. Actually, let's say not a proportional equality. That's nice. Okay, next one. And now we can solve equations with proportions as well. So same trick. Now is the procedure, right? What do? We do G, we do cross multiply, right? G times negative, well, let's put negative 4G. Just do that, that's nicer. Okay, equals, and then 8 times 2 is 16, and 1 decimal place, 1.6, right? All right, and solve this guy. I'll just divide here. Divide, which is the same exact thing as multiplying the reciprocal. Same, but looks different, right? So let's cancel these guys. I'll cancel out. I'm left with G equals 4 goes into 16, so just bring the decimal, right? Oh yeah, and then here's a trick, disco, staying alive, right? Maybe if we did this in class once. This is your foot, This is your hand that goes up, right? So this 1.6 goes inside, and this goes outside. Anyway, so that's going to be 4, right? And it's negative, and the decimal's right there. So it's negative 0.4, right? So G is negative. I'll put a 0 in there just so it looks nicer. There we go. So if I put negative 0.4 or 8 over negative 0.4, then it's the same as negative 4 over 0.2. And then finally, we'll do this one, cross multiply. And again, I don't know, you guys probably saw this stuff, but I just think, you know, it's really, this one's actually truly something you can use like in your daily life. So it's kind of nice to get that once in a while in math, because sometimes it seems so abstract. Okay, so 30 over 7, we cannot simplify this, equals L. Alright, those cancel, right? So we're done. Look at that. So if I had 30/7, you know, over 10, that's equivalent to 3 over 7. Okay, and you can see how that works. Alright, I hope this was helpful, guys.